All right, 7.3, the very last section of the class, parabolas. All right, we've already dealt with some of these shapes whenever we dealt with quadratic functions, right? So we have seen these as quadratics. And they're still quadratics. It's just we saw these equations before, right? Ax squared plus bx plus c. We called that a quadratic equation at first, and then we called it a quadratic function in chapter 3. But we know about quadratics, and we know that when we graph them, they are parabolas. And we also saw this form of the quadratic, which was just another way of writing a quadratic function. Both of these were parabolas, right? And we said the a value tells us whether it opened up or down. So now the only difference here is we're also going to be looking at sideways parabolas, which are not functions, right? Like a hyperbola is not a function, right? Because it doesn't pass the vertical line test. Same thing here. When we have a parabola that opens up along the x-axis, either toward the positive or negative x-axis, these are not functions. When it opens along the y-axis, it was a function, right? We looked at parabolas like that, and those certainly fit the description of a function. So notice that this conic section, this parabola that opens up along the y, there's the only one that's a function in this chapter, right? Circle, circle is also a conic section, but we talked about circles in a previous chapter. Circle is not a function, an ellipse is not a function, a hyperbola is not a function, this parabola is not a function. So this is the only one that's a function. Even though we're looking at all these things, realize, you want to remember our lessons from the past. That's the only one that's a function, is this one. All right, so we're going to look at now at a third type of equation for parabolas. Okay, so in this section, we are going to look at parabolas in this form. They're still the same thing, but now we're going to, because we want to take into account this case also, as well as this case, we're going to look at it like this. So when we're going to have an x and a y and this p-value. This p-value is going to come into play in a minute. We'll talk about it. The x and the y are variables just like before, two variables. When the squared term is the y, that's when we're talking about a parabola opening along the x-axis. Right? And depending on if this value here is positive, then it's opening that way. If this value 4p is negative, then it opens the other way. We'll look at different, I guess I can just put that here. Let's say when 4p is positive, and this way when 4p is negative. And this is another way we'll see, and this is opening along. This is the ones we saw in chapter 1 and chapter 3, right? When we had y as a function of x. And this opened up along the y-axis, or again, downward. So this one goes here, with these, and the x squared. When the x is the squared term, then it's opening up or down, and depending on the sign of the 4p. 4p is greater than 0, we're looking up. If 4p is less than 0, then it's moving down. So the things we want to identify in a parabola. So let's just take any generic parabola here. Let's take the one we're most used to, x squared. So in this case, we're looking at this case. We're interested in where the vertex is. Okay, this is called the vertex. We're interested in where the focus, there's only one focus for a parabola. And we are interested in what we call the directrix, which is the line that is the same distance that the focus is from the vertex. Okay, the focus is always inside the parabola. Okay, if it opened down, then the focus would be this way, but this one's opening up. The focus is always within the parabola. The directrix is the same distance from the vertex to the focus in the other direction. And in this case, it's a horizontal line. If the parabola was opening along the x-axis, then it would be a vertical line. So we call this the directrix, this line. We want the vertex, the directrix, the focus, and then we're interested in this line here that goes to either end of the parabola and goes through the focus, and for some reason unknown to anyone, this is called the latus rectum. Yeah, I don't know why. But that's what it's called. So those are the things we want to identify about a parabola. We want to know where's the vertex, what direction is it opening, where's the focus, where's the directrix, and where are the endpoints of that latus rectum. And let's see, all this stuff is nicely summarized for you on page 690. I'll give you probably better pictures than I'm drawing. All right, so same types of questions. So let's say the question is, graph the parabola. And you're given an equation. Y squared equals 8x. So immediately we see, we want to identify which way is the parabola opening. So we see the squared term is on the y, and the 4p, in this case, 4p is 8. Right? The value in front of the x is the 4p, so that allows us to solve for the p-value. The p-value is going to tell you how far from the vertex you go to find the focus and the directrix in either direction. Right? So we know that this is going to be a parabola, and same idea with the center, x minus h. H is the x value of the vertex. I'm sorry, in this case there's no center, it's just a vertex. The vertex is at hk, again x minus h and y minus k. So again here that you look at, if the x is alone, it's x minus 0. If the y is alone, it's y minus 0. So we know the vertex here is at 0, 0. And the 4p is positive. The squared is on the y, so we know it's opening along the x-axis in the positive direction. So we got a parabola that looks like that. And we know the center is at, or the vertex again, sorry, the vertex is at 0, 0. The p, okay, so the number in front of the x is 4p. We solve for p, we get 2. So we go 2 units over to find the focus. So we know the focus is at 2, 0. We know the latus rectum is going to be the line that goes through the focus and connects to the points on the parabola. The length of the latus rectum is always equal to the absolute value. Length of latus rectum is always the absolute value of that 4p. So in this case, 8, so that's the length. So we're going to go 4 units up and 4 units down. So 2, 0, we're going to go up to 2, 4, and down to 2, negative 4. And we want the directrix. If we want 2 units to the right to find the focus, we go 2 units to the left, and that's always going to be parallel to the latus rectum, the directrix. In a vertical line, remember back to our discussion of equations of vertical lines, it's just x equals whatever value that vertical line is going through. Okay, so these are the things we want to know about a parabola. First of all, what direction is it opening? Is it opening this way? Is it opening this way? Is it opening up or down? Where is the vertex? Where is the focus? Where is the directrix? What is the length of this line connecting the endpoints that goes through the focus? All right, so those are all the things we want to determine about a parabola. So let's look at a couple other examples, make sure we understand this. All right, so same question. Graph this parabola. All right, so notice this one had the y squared and the x to the first. This is the opposite, where the x is the squared and the y is raised to the first. Here the value in front of the y value is negative. So this tells us that it's going to be a parabola. And again, the center is at 0, 0 here, right? X minus h and y minus k. Sorry, again, vertex, not a center. Vertex at the origin. Negative value opening up or down. The negative tells you it's opening down. So we know it's looking something like this, with a vertex at 0, 0. So now we want to know what the p-value is. 4p is negative 12, so p is negative 3. So from the vertex, the negative value says you go down 3 units to get the focus, and up 3 units for the directrix. And the directrix, remember, in this case, is going to be a horizontal line. And the equation of a horizontal line is always just the number, y equals whatever number that line is going through. And that's up there at 3. Our focus is at 0, negative 3. Our latus rectum is the line that goes through the focus and connects onto the parabola. The absolute value of 4p tells us the length of the latus rectum. So we know that's 12, so we go 6 units to the right, 6 units to the left. Center at 0, 0. So 6 units to the right gives us 6, negative 3, 6 units to the left, negative 6, negative 3 are the endpoints of the latus rectum. And that's everything we need. Good times. Okay, so we have been given the equation twice and asked to come up with the graph. So similar to the previous sections in this chapter, sometimes we want to come up with the equation given some information about it. So here, let's say we're given information about a parabola. We're told the focus is at the point 8, 0, and the directrix is the line x equals negative 8. So we're given this information and we're asked, what is the equation of the parabola? And graph it. Right? It's always probably a good idea to look at the picture. All right, so let's look at that. If we try to draw it, we know this is a vertical line at negative 8. So we got our directrix here, and that immediately tells us actually a lot of information, right? Because now we know if the directrix is a vertical line, then we know the parabola is opening this way, right? Or this way. Right? So this now gives us the rest of the information we need. The focus is at 8, 0, so that's over here. So if the focus is here at 8, 0, and the directrix is over here at negative 8, 0, we know we have a parabola centered at the origin, right? Because it's the same, vertex at the origin. Because the focus is always the same distance from the vertex as the directrix is. Right? And if the focus is here, we know it's opening this way. Because we know the focus is always within the parabola. If the focus was over here and the directrix was here, then it would be opening the other way. Okay, so we know the vertex is at 0, 0. We know the focus is at 8, 0. We draw the line through the focus to get the endpoints of the latus rectum. And let's see here, since we know that the vertex is at 0, 0 and the focus is at 8, 0, that tells us that the P value is 8, right? Because the P told us the distance from the vertex to the focus. So we know P is 8. So given this information here, this tells us that P is 8, which means 4P is going to be 32, which is what we need for the equation, right? Because we want to write this equation. Since we know it's this direction, we know it's going to take the form of y squared equals 4px. Again, because of the given information, that tells us what direction it's opening. When it opens along the x-axis in either way, it's the y squared equals 4px form. And since it's opening this way, the 4p is going to be positive, and the p is going to be the distance from the vertex to the focus and the distance to the directrix. We multiply that by 4 to get 4p, and that's going to tell us, we know our equation is of this form from the given information. So now we're just going to plug in the 4p and get y squared equals 32x. And that's what we were asked to do. Come up with the equation of that parabola. All right, and just like with ellipses and hyperbolas, we want to deal with parabolas whose vertex is not at the origin, whose vertex can be anywhere. So again, translations of parabolas. So once again, two different forms that we're going to look at, just like before. The only difference is instead of just y squared and x, we now have y minus k squared and x minus h. That's this case, and like just the one we were looking at over there, opening to the right or to the left, depending on what 4p is, right? I want to write that, it'll look like a hyperbola. Or the other one, the other form, and that's the parabolas that are opening either up or down along the y-axis. All right, so this can open up or down anywhere along here. This can be right here or over here. This is what we're looking at now. All right, so same things. We want to know where is the vertex, where's the focus, where's the directrix, where are the endpoints of that latus rectum. Okay. So here we go. Given this equation, the equation of a parabola, notice the squared term is the x. So we're looking at this case where it's either opening up or down. The value of the number in front of the y term tells you that this one is going to open upward. Its vertex is going to be at positive 2, negative 1. All right, so vertex is at positive 2, negative 1, and 4p equals 4, which tells us that p equals 1. So we can start to take a glance at what that looks like. We know the vertex is at 2, negative 1, and it's opening upward. Focus is going to be 1 unit above that vertex. So this is the vertex, 2, negative 1. We know it's opening upward. Let's see what the y-intercept is, just to see here. If we put 0 in for x, we're going to get 4 and 0. So if we put 0, we get 4 equals 4y plus 4, so it's going to be 0. So just want to see if it went through the origin. it looks something like this. If we put 0 in for x, we're going to see it. We get a 0 for y, just to kind of get a good idea of what that looks like. The vertex is at 2, -1. And once we look at the number in front of the y term, that's 4p. We solve for p to get 1. We know it's opening up, so we move 1 unit up from the vertex. So instead of 2, -1, we get 2, 0 for the focus. So this is our latus rectum right here, the x-axis. And remember, the width of that is 4p. So the width is 4. We're going to go over 2 units to 4, 0. And the other endpoint is 0, 0. The directrix, we moved up 1 unit to get the focus, so we moved down 1 unit to get the directrix. In this case, the directrix is a horizontal line whose equation is y equals 1 unit down from -1, so -2. Okay, so we got the focus, we got the focus, we got the vertex, we got the endpoints of the latus rectum, we have the directrix. So that's what we're looking for there. And see, I think that's just about it. All right, that's it. See you next year.